Welcome to August 15th LeetCode Challenge, Minimum Window Substring. Given two strings S and T of length M and N respectively, return the minimum window substrings of S such that every character in T, including duplicates, is included in the window. If there is no substring, return the empty string. Test cases will be generated using answers as unique. A substring is a contiguous sequence of characters within the string. Example 1. We have the string here S and this string T. What we want to find is the substring of T, the string T within the subset string of S, such that it contains A, B, and C. So the minimum window able to find those three. So basically, we loop all the way to the end, and we find that B, A, and C is the smallest window substring that includes A, B, and C in the string S. All right, here's another unique solution here. We have A being we have S being a string of A and T being a string of A, and then we find the entire string of S, T being A, being in the minimum window of S. That's pretty much because they're both the same. However, both A's, we given example 3 here, we have S being a string of 1A and T being a string of 2A's. So both A's from T must be included in the window. Since the largest window of S only has 1A, we can't fit all the substrings of T into S. Therefore, we return an empty string as a result. So M is the size of S, N is the size of T, M is greater than 1, N is less than 10 to the 5th, S and T can compose of uppercase and lowercase. So yeah, that's pretty much find the minimum window of S such that every character in T is included in the window, including duplicates. Alright. So as the name suggests, we're going to use a sliding window approach here. Let's go for the hints. Create 2 pointers, create a window of letter S and T. Yep, that's what we're going to do. Expand and contract the window using 2 pointers using the sliding window approach. So that's what we're going to do using this, solve this. So the question asks us to find the minimum window of S, a string S, which has all the characters of a string T. So we're going to create a window that has a desirable amount of characters T within S. So we just simply slide the window, expand the window, contract the window. In any sliding window based problem, there's 2 pointers. We have the left pointer and the right pointer. The right pointer we're going to use to expand the window, and the left pointer we're going to use to contract the window given what we have so far. At any point in time, the pointers will move and one remain fixed. So the solution itself is classic sliding window problem. So what we do is expand the window by moving the right pointer, and then the window has a desirable character. We contract it if possible, and then we're going to return the minimum on the smallest desirable, the minimum window substring. All right. So to do that, we're going to write an algorithm to solve it. All right. So I'm going to initiate a couple things. First of all, I'm going to initiate a counter, which is going to count the number of characters. So I'm going to use the default dict of ints. And then I'm going to loop through for each character in T. What we're going to do is increment the counter at index character. We're going to count the number of characters inside the string T. And then I'm going to initialize a I don't know, counters. Well, I'm going to call this maybe make another variable called count. I'm going to make a left pointer and they're both going to be assigned to 0, 0. Now I'm also going to initialize a result. No, I'm going to call it output, and then call this we want the minimum length. We call it min length. Len. Yeah, sure, that works. And the result's going to first be an empty string. Use this actually. And then the minimum length so far, which we have the length of s. So this is the maximum length of the character s so far. So what we're going to do is actually decrement from it. Alright, so we initialize some things. So next we're going to loop through the character of s. So for index I, for index and character in enumerate string of s, what we're going to do is we are going to decrement our counter, right? If we loop through our character in s, then we're just going to decrement the counter we found in t. I'm just actually going to name this counter t, just to make it a little bit more succinct, because this is a counter in numbers characters in t. And we want to actually increment the character count in there. Alright. So if counter in t at the character is greater or equal to 0, so when the character is in t, then what we want to do is increment our count by 1. Right? So when the character that we find, so the character in s that we find is in t, then we increment our count by 1. Right? Next we have while count is equal to the length of the character, the length of t. So if we're gonna move our left point, we're gonna move our sliding window now. Left plus 1 is less than the min length. So this is when we want to get the minimum substring. We're moving our pointer. We're gonna update the output. So we're gonna take the slice between the left pointer to I plus 1. Alright, we're gonna move the window, and then we're gonna update our min length as well to be the length of our output. And then we obviously have to increment the counter at t with s at left pointer 1. Next thing we want to do is if counter t s at left it's greater than 0. So this is when the left character of the substring is in t. Do you want to decrement our count by 1? And then we obviously have to move the pointer and then return the output after all this is done. And return output right here. Run the code. Alright. Counter. Looks good. Okay, accepted. Awesome. So time complexity would be big O of the length, big O of m plus n, right? Where m is the size of the length of s and n is the size of t, because we have to iterate through basically the length of t and the length of S, right? So big O of n plus m is a time complexity. For space complexity, it is also big O of m plus n, because the window size is equal to the entire substring of S, entire string of S, and the size of m is all the unique characters in T. So yeah, a big O of m plus n as well. Alright, that's it for today. Have yourself a nice one.